Boys and girls, ladies and gentlemen, we are going to be solving one-step equations with rational numbers today. Now, I understand that you might be getting the right answer without showing me your algebraic steps, but we are going to require that you show your algebraic steps, that you algebraically check your answers. So please follow along with me. Here's our first problem. We have negative 13.9 equals 2.5x. There are quite a few students and truthfully quite a few adults that aren't very comfortable having the x on the right side of the equation or their variable on the right side of the equation. If you prefer to rewrite this problem using your symmetric property so that your x is on the left side, that is fine. So we get 2.5x equals negative 13.9. You certainly don't need to, but there's a lot of students and adults that are more comfortable with the variable being on the left. We need to make sure we are showing our inverse operations when we're solving these problems. Inverse operation means that if what is currently being multiplied, we are going to divide both sides of the equations. Yes, you have to show that you are actually dividing both sides of your equation by whatever number. So in this case, we are going to divide both sides of our equation by 2.5 because our variable is being multiplied by 2.5. And the inverse operation of multiplying by 2.5 is to divide by 2.5. Now, I cannot do this division problem in my head, but I'm not going to do it right underneath either. I'm going to take some space out on the right side of my paper or somewhere else on my paper to do my scratch work. Your algebra should look consistent. The equal sign needs to be coming down each step, and you want it to basically line up, but I don't expect you to actually get out a ruler. Now, you need to show that you're using your inverse operation. So if something is being multiplied, the inverse operation is to divide, and you need to have your answer. Be careful. In this case, our answer is x equals negative 5.56. The answer is not just negative 5.56. It's x equals negative 5.56. I'm also going to ask that you are checking your work. To check, you're just going to substitute the answer to your variable back into the original equation, substituting what you got for the variable back into the original equation. Now, I don't need to resolve this problem. I'm just going to simplify this right side of the equation and make sure it works. Again, doing my scratch work off to the side. Notice that I showed my algebraic steps to solve. I showed my check. I actually did the math to check. All of my scratch work is off to the side so that my algebra looks neat, but I still have my mathematical work showing how I solved the problem. Next problem. My equation says m over 1.4. Remember, that means m divided by 1.4 equals 0.2. The inverse operation of dividing by 1.4 is to multiply by 1.4. So I actually need to show that I'm going to take both sides of my equation and multiply by 1.4. Now remember, that's the same as 1.4 over 1, if you need to write it as a fraction. I'm actually going to do the scratch work, and I'm going to do it off to the side. On the left side of my equation, 1.4 over 1.4 is 1, and I'm left with m over 1, which is the same thing as just m. And on the right side of my equation, I found that m equals 0.28 or 28/100ths. Now again, I need to make sure I am checking my work. I'm going to substitute the 0.28 back into the original equation for m, and I should get something that is just true. I'm actually going to do the division to make sure that that really works. And of course, when I'm done checking, I should get something that is always true. 0.2 does always equal 0.2. So I know my answer is right. M equals 0.28 or 28/100ths. Again, notice I showed my inverse operations, my scratch work is off to the side, and I showed my check. Next problem. We have 3/4 x equals 9, or 3/4 times x equals 9. Now, the inverse operation of multiplying by 3/4 would be to divide by 3/4. But when I have a fraction that my variable is being multiplied by, I'll often write that as that I can also use my multiplicative inverse. The multiplicative inverse of multiplying by 3/4 is to multiply by 4/3. Now that really gives me the same value as dividing by 3/4. And again, if you need to, you can always put your whole numbers over 1. Now, looking at the left side of my equation, I get 3 over 3 is 1, 4 over 4 is 1. So on the left side of my equation, I'm left with just x. On the right side of my equation, I'm going to go ahead and factor this 9 to be 3 times 3. 3 over 3 is 1. And I'm left with x equals 12. Again, we always want to check our answers. To check, you're just going to substitute your answer back in. Again, I can always put my whole numbers over 1. And what I would get would be 36/4 equals 9, or 9 equals 9, so it checks. Okay, this is the last one, I promise. So now looking at my equation, my variable's on the left. I see that my variable is being added to negative 8.3, or I'm adding negative 8.3 to my variable, either way. I want to use my inverse operations. I'm going to show my problem horizontally, but if you're more comfortable, I'm okay with you using the vertical method also. By horizontal, I just mean I'm going to line up my numbers from left to right. If you instead wanted to write plus 8.3 on this side and plus 8.3 on this side, I'm fine with that. So for this problem, I'm going to use my inverse operation, which would be to add positive 8.3, or my additive inverse. And if I add positive 8.3 to the left side of my equation, I also must add positive 8.3 to the right side of my equation. Again, I'm going to do my scratch work off to the side so that my algebra steps look neat. I get that x equals 10.75. And I always want to check, and again, you check by substituting your answer back into the original equation. We need to simplify the left side of this equation. I'm adding two numbers that have different signs, so I know mathematically I will have to subtract them. The 10.75 is bigger, so I know I would have to put that on top in order to do the subtraction. In the end, I'm left with something that is just true, so I know it checks. Now, we're going to be going over these problems for a while now, so you need to make sure that you can solve an algebraic equation algebraically. We're just doing one-step equations. You need to make sure you are showing all of the steps algebraically. Your scratch work should be somewhere off to the side so that your algebra part of it looks neat. I want to see the check, and I should be able to see the math that matches up with the check to see that you are actually checking these problems. Okay, I hope this helps, and we will review it in class on Monday and next week if you need any extra help.